All right, next up, we have New Frontier Aerospace, and this is some cool stuff here. So Bill is going to talk about his two-stage 3D printed, I don't want to call it a motor, correct? Not a motor. Is it an engine?
What we're going to talk about is Hypersonic VTOL to solve some of DoD's logistics and challenges. Some of the things that the Colonel just talked about, we'll talk about some possible solutions. And I was thinking this could be tested there. So that's it starts with propulsion, but it ends up solving a lot of DoD challenges.
Right. Yeah, and that was something that the Colonel didn't mention. That, and you correct me if I'm wrong, Colonel, but you do have the ability to do hypersonic testing in Grayling, correct? You have a hypersonic range.
More so in our Alpena complex.
Right.
But it depends, right? So it depends on the distance and some of the other stuff. But yes, we are doing a little bit of that this next summer. But there are limits to that range as well.
All right, thank you. So I will go ahead and turn this over to Bill Bruner, and take it away, Bill.
Thanks, Eugene. Thanks for the invitation, and thanks for listening in, everybody. So I'm Bill Bruner, retired Air Force Colonel. I flew jets, supersonic F-111s in the Air Force. Then I was a senior manager at NASA, and so sort of that combination of air and space is why I'm sitting here. I'm the CEO of New Frontier Aerospace. We're a venture-backed hypersonic VTOL and propulsion company. Because we use rocket propulsion, advanced 3D printed engines. I've got one sitting here behind me. We are both an aerospace and a space propulsion company, and NASA's funding us to do some in-space propulsion stuff. So I just pretty much read the elevator pitch. We're applying space and hypersonic weapons technologies to the Army and the DoD's challenges of troop transport, logistics, and sustainment in the Indo-Pacific theater and globally to deter or defeat the adversary. There is a contested logistics capabilities gap. You've heard a lot of talk about it. The adversary has published videos that shows his plans to contest our access to the Indo-Pacific theater. There are animations online of them staging precision missile attacks against Taiwan. And there are videos of them online conducting simulated attacks against Guam. And so the commander of Army Futures Command says, we know we've got to get better at addressing this problem. Just more on that on the next slide. And the Army's idea is, well, what we're going to do is make sure that whatever solution we come up with is also a threat to the adversary. Projectiles, 40 individual aim points. So future R&D funding, we're looking for venture funding. We've got $200,000 in pre-seed from private investors, about $2.25 million from DoD to finish the engine. We raised that $133,000 I mentioned in non-dilutive from the New York State Energy R&D Authority through the Venture for Climate Tech Accelerator because of our climate case. We're also working under NASA contract to develop an orbital transfer stage powered by our engine, and that funding will benefit DoD and the Hypersonic Vehicle Theater Transport Program. Let's see here. Let's switch. So our development path is incremental. It's crawl, walk, run. We've done a subsonic flight demo, hovered, a 3D printed plastic, about 4 foot tall model. We're going to hot fire and that was an avionics demo more than anything else. We're going to hot fire the engine in the next couple of months. And then for about $1 million, $500,000 to build the airplane, $400,000 to hover the airplane, another $1.5 million to get to a supersonic flight test. So that's about $2.5 million to build a first demonstrator. And then we'll develop the software and our operational concepts. We've talked about with some of these barge companies about doing a sea-based demo. And then we'll raise the money that we need to build a 3-engine vehicle that has real military capability that we just talked about. So supply chain, bottom line, engines primarily printed from nickel alloys, and that the purple on the map is where nickel comes from. And so it's not one of these strategic materials that we need to buy from our adversaries. Our subcontractors for printing the engine and eventually the airplane are all US based. At scale, we'll bring that in-house with a Meltio. We're looking at a robot arm and a print head that is made in the United States. Our fuel is liquid natural gas. The U.S. is the world's leading LNG exporter. So we believe the bottom line is this is a near-term, affordable solution to the country's tyranny of distance challenge. And that is the last slide. And I'm standing by for any questions that you might have.
All right.